Hello there. Last week we talked about the data science life cycle. We talked about these 5 steps that our book lays out as being part of this very important life cycle of data science. We specifically spent some time talking about the first step called stating the question. And that was what they talked about in chapter 3. We talked about the types of questions that we might start with. We talked about characteristics of a good question, and we also talked about how we can apply the epicycle to this step. Today, we're going to talk about the next step called exploratory data analysis. Now, in the book, that's covered in chapter 4. The authors start with a case study. They talk about that they have a question, and then they have a data set, and then they go about throughout this chapter going through these different tasks that would help us be able to explore this data. So they remind us, first of all, in 4.2, that we need to start with our question. So hopefully we already have our question formulated by the time we get to this step, but they're just, I guess, emphasizing that here in 4.2, to start with our question. So in the book, their question that they are wanting to ask is, do counties in the eastern United States have higher ozone levels than counties in the western United States? So then they go about performing these different tasks to help us in being able to explore our data. So first of all, we need to read in the data. Then they talk about checking the packaging. We'll talk later about what that means. Then they say, look at the top and bottom of your data. And then always be checking your ends. And we'll talk about that too. Then they say to validate with at least one external data source, just to make sure that our data is really, what we should be expecting, and that that we're, not off track somewhere. And then 4.8, make a plot. And then 4.9, try the easy solution first, meaning let's see if we can maybe give a stab at answering our question, the question that we started with in 4.2. And then 4.10 is follow-up questions. So we're going to go through each of these and talk about what each of these steps involve. Now, the book lists a link that that will tell us where they found the data that they are using, but it turns out that that data is no longer there. The site's not set up the same way as it was before. There's a new site, but then that site does not have the specific data that this book covers. So, and I was not able to find that data. So what we're going to have to do is use a different data set and ask a different question. I've come up with those two things, a different data set and a different question, but we're still going to perform each of the tasks that are discussed in chapter 4. So we'll still go through all of this. We'll just actually have a different case study that we'll be working with. I wanted to find a data set that also involved ozone, so I went out and found this data set. You see the link here, and what it is a data set where the air quality was measured in New York every day from May to September in 1973. So measurements were taken, and here are the measurements that were taken every day during that time frame. The ozone level was taken at Roosevelt Island at a certain time, 1 o'clock to 3 o'clock p.m. So that was done. That's the first column in our data set involves that mean ozone in parts per billion. Then the next column represents the solar radiation. So they found the solar radiation, again, from a certain time. That is in the morning, 8 a.m. to 12 p.m. At Central Park. Then the wind speed was measured, and again at another different time, but still on the same day, at LaGuardia Airport. And then the temperature, the maximum daily temperature was measured at LaGuardia Airport. Now, so we have that data. So our question is going to be, does the ozone level tend to rise when the temperature rises. Now, I do want to make a note that in our book, the author uses the R programming language in order to explore the data. And definitely the R programming language is something that many people use. I'm eventually going to teach you how to use Python to do the same things. But before we even do that, I'd like to introduce you to some software called KNIME. And this is some software that I think will be really great for us to use here at the beginning, because we don't have to worry about just really anything. It's a drag and drop interface. It's really easy to use, so I wanted you all to use that first. So KNIME is the reason I had to look it up. I wasn't sure what those letters stood for, and they stand for Constance Information Minor. Constance, there's a University of Constance, and that's where they had a team of system engineers create this software. So that's what the name is referring to. So here's what we can do in KNIME. We have workflows that we create. So I've got a little video on Canvas that you can look at, kind of take a look at that as kind of a short little introduction to it. So that might be good for you to look at and at some point. And then today here we're going to talk about how to use KNIME in order to perform these tasks that we need to do in order to explore our data. Now, to download KNIME, this is a completely free software, so you don't have to pay anything. And it looks like when you go here to KNIME.com downloads, it looks like you're going to have to register, because they have these different tabs 1, 2, and 3, and the first tab is selected, and it says register for help and updates. So it kind of almost looks like they're going to make you do this before you go on to the next tab, which is downloading KNIME. But it turns out you can totally skip that first step. So you don't even have to type in anything for that first step. Just click on 2, and that'll take you to the tab where they will let you download KNIME. So just go on to step 2 and go ahead and download KNIME. Go ahead and do that on your computer so that you'll have that and be able to use that here for today and then for some labs coming up. Okay, so now in this chapter, as I said, they go through these different tasks that we need to accomplish in order to explore our data. And again, the first one was formulating your question. Again, that's something that we probably already have, because the first step in the main data science life cycle is stating and refining your question. So you'll really already have that question by the time you come to this next step of exploratory data analysis. But anyway, I guess the authors just want to emphasize that you are starting with a question. So they want you to formulate your question again, state your question. And so our question for this example will be, does the ozone level tend to rise when the temperature rises? Now the next step then is to read in our data. This is, we've already talked about what the data is going to hold, and you see here down this little table, if you pull up the data in Excel, you see that you have something that looks like this. There are column headings for ozone, solar radiation, wind, temperature, and then the month and the day. And then all of those values are in there. So each record, each line in our data would represent a different day of a particular month. And so for the first line here, you see it's month 5, day 1, so that would be May 1st. The next one is May 2nd, and so on. Notice that this data has column headings, but doesn't have row headings. So over on the left of this little table, you see 1, 2, 3, 4, 5, but that is what you see in Excel, where Excel is just labeling those lines. But the data itself is in the white area of this table, and you know that you see that the first column starts right away at the ozone levels, and there's no column that has some kind of an ID number or just a row identifier. A lot of times there's just row identifiers where it will say row 1, row 2, row 3, and something like that. There's nothing like that here. Column headers we have, row headers we don't. That's something to keep in mind here when we get ready to use KNIME in order to read in the data. Okay, so in order to use this data, first of all, go ahead and download the CSV file that I've posted on Canvas. It's called airquality.csv. It's right there in this week's section. So go ahead and find that, download it, and you're going to want to save it somewhere, probably wherever you're saving your information for this class. So go ahead and download it and save it somewhere. And then we're going to open up KNIME. So hopefully you have KNIME installed already. Now what I'm going to do is talk over these slides, talk about what we're going to do in these slides. But I know it might not make a whole lot of sense sometimes if you're not actually doing it yourself. And it's possible, if you want to go through these as we're going through these slides. After I talk about it, you can pause it and then go ahead and do it yourself. But I think something that will work better is that I'm going to also have, within this video, I'm going to, after I talk a little bit about it, I'm going to show you how I perform these tasks. So you'll see my screen and you'll see me doing all of these steps. So hopefully that will be even better to help you understand how to do all of this. So anyway, like I said here, this will be in the notes, so you can always go back to these slides and see how I have all of these steps laid out. But again, you might want to actually watch my video in the part of the video where I actually perform these steps. Okay, so first you would open KNIME, and then you would choose File, New, and then you would choose a new KNIME workflow. So you see this picture here, says it will, after you say File, New, you see this little wizard, and you want to choose the new KNIME workflow option. Then over the bottom left, you see this little window called the node repository, and that's where we have all of these different possibilities for nodes that we're going to drag over onto our workspace. So in order to read in our data, we need to drag a node over into our workspace that's going to perform that task of reading in our data. So these nodes are in different categories. So this particular node that we're looking for is under the I/O category, which is input output. So we find the I/O line and then find under there the read section, and then go into the read section and find the CSV reader. So the CSV reader is going to be reading a file that's in CSV format. Now, a lot of the data that we work with in data science has already been saved in this same format, the CSV format. CSV stands for comma separated values. So really it is just a bunch of text that we could read in Notepad or anything, and it just has these values, and then it has a value, then a comma, value, and a comma, and so it's the commas separate these values, and then at the end of the line it starts on a new line with another value and a comma, value, and a comma. So really all that is needed are these values, and the commas say where to separate them, and then anything like Excel or this KNIME or anything can read that and see that the first line is the first record, the second line is the second record, and so on. And so it's able to pull in these values just by knowing that each of these values is separated by comma. So anyway, that's what a CSV format is. And so if our file is in CSV format, we would want to drag over this node called CSV reader onto the workflow. Once you drag over that node, if you take a look at that node, you'll notice that down here at the bottom of the node, it has some little lights, kind of like stoplights. They'll be red, yellow, or green. Red means you can't go any further until you configure this. So you need to right-click on that node and then choose this configure option. Then it will bring up this dialog here, and basically it first of all asks, let's see, it first of all asks where is the file we are going to want to read in. So you need to just go find it, click that browse button and go find the file that you want to read in. The other thing that's important to do, everything else is usually okay, but here for has column header and has row header, here we already noticed that our data has column headers because we have ozone and solar and wind, and so those are the headers for our columns. But remember, we noticed that there's no headers for the rows. It starts out, the data itself starts out with just a bunch of ozone measurements. So we want to make sure and uncheck this has row header option. So be sure and do that, make sure that's not checked, and then click OK. Now once you have configured the node, then that red light down below at the bottom of the node has now turned to yellow. So that means that configuration is complete, but now we need to make that, in order to get that light to turn green, we need to execute that node. So we right click on the CSV reader node and choose execute, and then the light now will be green. And that means that everything has been done. We dragged it over, we configured it, and now we executed. So really, once the light has turned green, that means the data has already been read in to KNIME. At this point, you might want to go and watch the video called Read in Your Data to see me perform this step. After reading in the data, the authors suggest we check the packaging. Basically, just look and see what's in there. How many rows does it have? How many columns does it have? What's the structure of the data? So right-click on that node again and choose File Table like we did in that last little video. And you'll see the data. It looks like this. And there's some important information right there. You'll see that it says up there at the top how many rows there are and how many columns there are. So right away we can answer those first two questions. There are 153 rows and there are 6 columns. And what is the structure of the data? Well, it's pretty easy to see what the columns are like. We already kind of knew what to expect, but once we read the data in, we kind of want to go in there and double check, make sure it all came in correctly. And so we see here again from this file table that we have the columns that we've expected. Ozone, solar radiation, wind, temperature, month, and day. The next step is just to look at the top and bottom of the data. We're just getting an idea. Do we see anything so far as is it in any certain order? Is everything looking okay? Are there strange things going on at the end of the bottom of the data, like all of a sudden all of the rows, the rows are only halfway filled or something like that? It's just a kind of a quick look at the data. So look at the top and the bottom of your data. And the way you can do that is, again, use that file table and scroll up and down. I'll do a video of that here in just a second. Now you can watch me perform this step by looking at the video called Look at Top and Bottom. Now the authors suggest to always be checking your ends. That's basically saying look at the data and see how many of what is in there. So what we would do, we already have the CSV Reader node on there. We're going to be dragging over a statistics node, and I will go into detail here in just a minute where when I show the video, I'll go through it, and it'll be easier for me to explain as I go what's going on. But if the big picture is we're going to be dragging over this statistics node and connecting it to our CSV Reader node, and then we're going to configure it and execute it, and then we'll be able to look in a table and see if we can find out some information that we're looking for. So once we once we drag over that node and look at this statistics view, we'll see down below we've got the options of statistics table, nominal histogram table, and occurrences table. So you can look at any of those. If we look at the statistics table, we see that we have talks about all of the different columns over on the left here, and then it tells us the minimum of each of those, the maximum of each of those. So that might give us a little bit of something we can go by. First of all, we see that we aren't really familiar with the levels of ozone or solar radiation or anything like that, but we can at least look at the months and the days. So we know that this data is supposed to be data from May through September, and when we look at the months, we see that the minimum is 5 and the maximum is 9, and so that makes sense. That sounds like the months May through September. And then also the days, we see days 1 through 31. So it's looking like we kind of have the right number of months that we had expected and the right number of days that we had expected. So those are valid month numbers, and then the day ranges too. If you look down for the day line and you see down at that bottom line over to the right, it shows a histogram showing it. What that means is it's got a bar at each value that shows up in the data, and it's showing us basically that there are no values between 1 and 31 that are missing. We've got about the same in each of those. Notice at the very end at 31 the bar goes down, but that's because not all months have 31 days in them. So 31 would not always be there for a month. Another thing that we can do is look at the occurrences table. If we open up the occurrences table, we would see the information kind of in a different way, but we would arrive at the same conclusion. So in this table here, it shows the months, first of all, and it says that underneath month, it says 5, 7, 8, 6, 9. It's just not in order, but that's really just 5 through 9. And then it says how many of each of those, how many records had a month of 5, and there were 31 records with a month of 5, and you can see for each of those months how many there were. For 6 and 9 there were only 30 records, and that makes sense because June and September only have 30 days in them instead of 31. So that's making sense. Also, if we look over at the day column, we see the days go from 1 up to, all we can see is 30, but if we saw further down, we'd see that it goes all the way to 31. And then next to that day column, it's telling us how many have that particular day for that record. So for day 1, it looks like there's 5 records with the day 1, 5 records with the day 2, and so on. If we could see that last line, we would see that there are only 3 records that have a value of 31 because 6 and 9 months did not have 31 days. Now you can see me perform this step by watching the video Be Checking Your Ends. Something else that we should do is validate with at least one external data source. So we already knew based on our prior knowledge that we knew what to expect for values in the month column and values in the day column. So that's what we looked at earlier and saw, yeah, it's what we expected. But when it comes to values that we're not sure about, like the ozone level, we might need to go outside, we would need to go outside this data and look at some external sources and find out, well, are these values, do they make sense? Do they seem to at least be roughly in line with what we should expect? And then just to make sure that maybe we don't have something wrong with our data, that we read it in, something got messed up when it got read in or something like that. So anyway, so for us, we might want to look at that ozone level and see if those values that are listed in our data are ones that seem to make sense. So what I did is I went online and searched for ozone levels. And so I found out that there is a standard that was set in 2008, and it says that the annual fourth highest daily maximum 8-hour concentration averaged over 3 years should not exceed 0.075 parts per million. Okay, ppm, parts per million. Now, when we looked at our data earlier, that when I first introduced the data, I didn't point it out, but those values under ozone have a unit of parts per billion. Okay, so they're listing parts per billion. This is parts per million. So what we're going to need to do in order to compare these values is change our 0.075 parts per million into find out how many that represents in parts per billion. So what we would do is we would take the 0.075 parts per million and then multiply it. It turns out then we'd be multiplying it by 1,000, and that gives us 75 parts per billion. And so that's then the value we're going to be looking at, 75. We're going to look at our ozone levels in our data and see if it's somewhere, if they are in that ballpark somewhere. So if we look here, we see that for ozone, the minimum value was 1. The maximum value is 168. Now, the 75 is what we're looking at, and 75 is kind of in the middle there. We might be concerned because that maximum is way higher than the 75, and that 75 is, a type of a standard. But I think, I don't have the histogram showing here, so we don't know how many of those high values there are, but I don't think there were very many of them. And also that standard had to do with an 8-hour concentration. So anyway, I guess that's a different kind of question that we could be asking, but at least we see that 75 does fit in to this range between 1 and 168. So we know that, okay, that nothing seems to be wrong here. If we saw that if our data had claimed, the information that we got along with our data set had claimed that these values were parts per million, then we'd be comparing the 0.075 with these values here of 1 up through 168. And that 0.075, we would say something's wrong because all of these are way higher than the 0.075. And that would be then because maybe we were, the people who had created this data set were wrong, and it was really supposed to be in parts per billion, but they had told us it was parts per million. So anyway, you're just double checking everything, and at this point we just we do see everything looks okay for us right now, that we knew it was parts per billion, and when we changed that 0.075 that we found from an external source, changed that to parts per billion, we got a number that kind of fits into this range, so we're not too concerned. Now the next step is to make a plot, some kind of graph, and as many graphs as we want, that's all the better. So in order to do that, we're going to drag over another node called a scatter plot node, and then connect it to the the CSV reader node, and then we're going to execute and see what we get. When we execute it, we're going to get these scatter plots, but we have to look down below and make sure where it says X column, Y column, that we see what features are listed there, because what we're interested in might not originally come up as because there's going to be a default two that are being compared when you pull that scatter plot over, and maybe those aren't the two that you care about. So always look down there and see what two are being compared. I probably had to change this to ozone and temp, because that's our question, is how does ozone and temperature, how are those related? So that would be the scatter plot we'd be interested in. So I went down and changed that X column to ozone and the Y column to temperature so that we can see how those two are related. We can also drag over a scatter matrix, which is like a scatter plot, but we see a lot of different scatter plots together. And so we can do that and also look at that. And when we do that, you see something like this. And I'll talk a lot more about this here when I show you in the video, when I go through these steps in the video. And here's another view of the scatter plot where we have taken everything out except for, you see, everything in the little red box. That's what we're not looking at, that we don't want to see. And then the only thing that we do want to see is in the green box, and we just have ozone and the month. And so that's another view that might be interesting to look at, and we'll talk about that as I actually perform this using KNIME. Now watch the video called Make a Plot to see me perform this step. Okay, we are almost done. We are down. We've started with step number 1, and we're down to step number 8. Step number 8 is try the easy solution first. And these aren't steps that are all supposed to be done in any order or anything like that. These are just different tasks that the book is suggesting that we do. But by here at the end, though, they're saying, now once you've done all those previous tasks, let's think about this. What's the simplest answer we could provide to our question? So we go back to that question that we formulated, which was, does the temperature level affect the ozone level? And so we ask, you know, what do we think the answer is, just off the top of our head, just based on what we've seen just in this one step? We haven't built any fancy models or anything like that, but we're just kind of just saying, what do we think? So we don't worry about whether the answer is correct or not. It's just that we're just, later we might get into it deeper and find that it's really what we've decided here at this step number 8 wasn't even correct. But just a quick, what's my intuition? What do I think based on what I've just seen? Okay, so and what they say is, what they're saying on this step, I'll just read what they say here. It says, importantly, if you do not find evidence of a signal in the data, using just the simple plot or analysis, and by that they mean, if anything that you saw if it didn't seem to even answer your question at all, there was nothing to be found in the data that you would be able to even start with to be able to answer your question, then it says, then often it's unlikely you will find something using a more sophisticated analysis. So it might be the point, if you aren't able to come up with either a strong, yes, I think that there could be something here, or yes, it looks like this proves that no, there is no correlation. If you can't find something that at least kind of gives you a strong indication one way or the other, then maybe it's not even worth continuing. So for us, we saw that scatter plot, and it looked like we saw that those higher levels of ozone did indeed happen when the temperatures were higher. So based on this, we would say, Yeah, it kind of does look like ozone levels appear to be affected by temperature, and maybe we can look at that further in some of these other, as we go further into building models and evaluating them. But now that we've come up with our easy answer, we don't want to stop there. We at least know that there might be something to this data. This data might help us answer our questions, but we always want to be thinking about challenging our solution, thinking of ways to challenge the results. For one thing, could there be some confounding variable that we're not aware of? We might say that one feature causes the other feature to change, but maybe there's a third feature in the background that's really in charge of making both of those change. Or also, is the data biased? Was it collected in a biased manner? That's always something too that we need to continually be thinking. Now we get to the last step of asking ourselves some follow-up questions. Do you have the right data? Do you need other data? And do you have the right question? So the goal of this exploratory analysis step is to get you thinking about your data and reasoning about your question. And at this point, maybe we have found, based on these questions, the answers to these follow-up questions, maybe we've found we don't have the right data. We need some other data. Or maybe the question is not a question that's even answerable with this data, or maybe we've determined that it's not a question that we care about to begin with, now that we've thought about it. So this, what the book says is at this point we can refine our question. If some of these answers to these follow-up questions aren't as we had hoped, we can refine our question or collect new data, all in an iterative process to get at the truth. So this is where the epicycle comes in. We might have gone through all of this and then decided we, really we don't want to continue with this whole process anymore, and we want to change our question, or we need to find more data. So again, this epicycle is always double checking, thinking, am I making progress? Am I where I want to be? Do I need to change something? So that's the last step that we need to be concerned about. Okay, so I have a lab assignment that I'm assigning here for this week, and that involves I'm going to give you some data and give you a question, and then I'm going to have you go through all of these different tasks that we've just done with this question about the ozone that we did here today. I'm going to have you go through all of that with this new question and this new data set. So I'll kind of walk you through that, so you can go ahead and pull that up in Canvas and fill out that document, and then that'll tell you what you need to do. Also, don't forget about the quiz that will also need to be done, and there is also, again, a discussion assignment too. Okay, have a good week. I'll talk to you next week.